So in my introduction video to linear equations, I talked about buying shirts, right? We take that information, we've got one number line and another number line, we're putting that information together, and that's going to tell us a story. It's going to tell you the story of how I buy shirts, right? As boring as it might be. So what if I change my story up just a little bit, okay? Because we already had this first orange line that we were looking at, where every 6 weeks I bought 2 more shirts. 6 weeks goes by, 2 more shirts, and so on, right? So let's say now I'm not starting with 0 shirts. Sad Mrs. Landers with 0 shirts. Now I'm going to start with 3 shirts in my closet. Okay, so now I have a different starting point to my problem, right? After starting out with those 3 shirts, I get paid. 6 weeks goes by, right? I'm bumping it up to 2 shirts, okay? So after 6 weeks, I'm at 5 shirts, right? 6 more weeks goes by, we're at 12 weeks now, and that's at 7 shirts. And then 6 more weeks goes by, at 18 weeks, I'm up to 9 shirts. So you can see there's a slight difference between these 2 scenarios. My rate of buying shirts didn't change, right? I was still really boring and predictable about my shirt buying, but my starting point changed. And when your starting point changes, it's going to scoot your graph, or excuse me, your line up or down based off of what's happening, okay? So what we're seeing here is that we have 2 boring predictable rates that I'm buying shirts at, right? And so that rate, the other word for that, the rate of change, is basically slope, right? The steepness of your line is going to determine the pattern or the predictions that you can make with that line. So we usually say rise over run because we look at the change in our y over the change in our x. And I'll tell you that confuses so many students because our brains so badly want to do x and y, x and y, x and y. Let's write that up down. No. For slope, we have to switch gears and we have to go up and then over. And the reasoning behind that is basically because it's going to make sense. As we change things, if we increase something, if we do rise over run or the change in our y's over our x's, that's going to have more common sense of an answer than if I were to do my run over my rise. So just remember, we're going to do rise over run. So what that looks like is if I put the numbers in for this, for these 2 lines, I've got my original story where I started with nothing, right? No shirts, but I go and I buy 2 shirts every week. At 0 weeks, I have 0 shirts. But at 6 weeks, when I got paid, I bought 2 shirts. 6 weeks later, I got 2 more shirts, and so on. The change in the up-down, okay? The up-down is my number line that's going up and down. That's the number of shirts. So the change in my shirts over the change in my weeks. So mathematically, I say that you could do this 2 ways. You could do it the mathy way or the graphy way, okay? So mathematically, all you're doing is finding the space between those numbers. And what happens when we find the space? We're just subtracting, right? So the space between 2 and 0 is 2, right? The space between 6 and 0 is 6. So think about that space on a number line, right? Our graphs are just number lines. So 2 minus 0 is 2, 6 minus 0 is 6, and I simplify that to be 1/3, okay? If you look really closely, you can see some yellow dots I have here, where actually if I went up 1 and over 3, it still hits my line, right? If I looked at 2 different points, any 2 points I wanted to, as long as I'm looking at the space between them, I could say 4 minus 2 and 12 minus 6, that's still 2 6, which simplifies to 1/3. Or if I could say 0 minus 18, or sorry, 0 minus 6, okay, gotta start with your y's first, right? 0 minus 6 over 0 minus 18 right here, it's negative 6 over negative 18. But again, that's going to simplify to 1/3. A nice, boring, predictable rate of change every time, okay? So that's our bottom line, our solid orange line. And then the one where I have my purple dots in there is, you can see we've got very similar connections, right? 0 weeks, 6 weeks, 12 weeks, 18 weeks, right? But I had started out with 3 that first week, remember? So every amount is going to be 3 bigger. I had 2 in my first scenario, then I had 3 more than that, which was 5. 3 more than 4 is 7, and 3 more than 6 is 9. So this is very close. Our slope should be the same, though, because I bought the same amount of shirts at the same rate. So if I said 5 minus 3 over 6 minus 0, that simplifies to 2 6, 1/3, right? 7 minus 5 over 12 minus 6, or 9 minus 3, or 3 minus 9, doesn't matter how you compare. Pick your 2 points and stay consistent. If I'm going to say 3 minus 9, I have to do 0 minus 18. If I say 9 minus 3, I have to do 18 minus 0. Any way you cut it, it's a nice straight line. You're going to get the same slope every time. So our slopes in these scenarios are the same, but there's something else that's different, and we'll get to that in another video.